photon interacts with a positive charge, we already know in physics that if you invert the charge, you invert time. That may surprise you, but it's well known in physics. That is not Tom Bearden. And so it gives you a little piece of negative time. Hey, wait a minute. We got a problem here. They use a theorem in particle physics. They found out that charge is not conserved, broken symmetry. Parity is not conserved. Time itself is not conserved, but it seems that the product of the three, all three, cannot be violated at one time. That's the best shot we got at it today in particle physics. That's where they're at. But you can violate any two or one. Let me say that again. You don't have to conserve charge. The contrary argument is, but it's a little effect. You say, yeah, maybe it's a little white crow, but maybe he'll grow. If I can have little white crows and I can collect them and grow them, I'll have big white crows in the maker world. So charge parity time, if you inverse the thing, you might get something different. As a matter of fact, the antiphoton, which has been assumed to be the same as a photon, that is a false assumption in physics, and I'll show you that in just a moment. Well, we've already said we go into the nucleus with scalar waves, and we'll have a higher order reality when we do that. Why? First place, we're interacting with a positive charge. The nucleus of an atom is already time inverted. Did they forget to tell you that in your electrical class? Yeah, because they didn't know that. But it's true, and modern physics substantiates it. And we're going to find out that's why we're going to get time reverse waves a little later on, that we can use to do all sorts of magic things. At this point, then, if you go into the nucleus, although I show here on this diagram little balls all clustered together, modern physics tells us that's not the way the nucleus is built at all. It's a vast boiling smear. There's not a proton, there's not a neutron, all that mess in it at all. If you go in there and you catch one and you gradually catch all the wiggling fish and bring them out, that's what you'll find on the average after you stop the fish. But before you stop them, they are waves. They are not particles. They're all mixed up as a big mess. So you can't separate them. It's a boiling mess. In fact, it's a trapped local potential, which means it's gravitational. That's what mass is. That's modern physics, not Tom Bearden. But now, if I can go in and have a wave absorbed directly in that, the scalar wave, I just either increase or I can decrease, depending on how I bias that potential wave that I send in there, and I can raise that potential and lower it at will. As a matter of fact, if I keep radiating it and absorbed in there, it'll keep building up. It charges up just like a capacitor, only now it'll charge either positive or negative. And I'm giving you laboratory results. It acts as a capacitance for scalar waves. Now, when something else comes in there and hits it another wave, it'll trigger the thing, it'll collapse, and out will come another wave out of the nucleus. It'll be a time reverse wave, and all the nuclei in the universe are continually exchanging scalar waves. I don't have time to go into this aspect, but I will say with the fourth law of logic, which I built many years ago and proved, I published a proof for it, so I don't have to worry about can it be proved. I can demonstrate it in less than 10 seconds. The fourth law of logic tells us ultimately you can only model a thing in terms of its direct opposite. It's not geometry, the modeling of the presence of mass in terms of the absence of mass. You see my point. In this case, we're going to have to learn a little bit of that in our modeling theory, and we'll go into that in just a moment. But when we go into the nucleus now in this boiling mess, and we can actually adjust the potential, we can even put patterns. Remember, we put fingers, structure inside this scalar wave. It's got a structure. We can build any kind of zero system, different systems and patterns and polarizations inside there in the virtual state of vacuum that we wish to. We can go into that nucleus, and it's boiling away. It's just like a cathode. You put a little signal in there, you put a matrix. That thing will organize. You know about Prigogine, you know about self-organizations of highly nonlinear systems far from thermal equilibrium. That thing is as far as you can get from thermal equilibrium. It's in a violent exchange with the vacuum itself, virtual particle exchange. It's a Prigogine system, first class. And that thing will self-organize according to the pattern you put in it. I've just told you how to do transmutation of elements. Between isomers is very simple. A man was nominated for the Nobel Prize, Kervran, in 1977 for proving conclusively that living systems with microvolts can transmute elements to a limited extent. Chickens do it, we do it, oats, barley, rye, wheat, everything does it a little bit. And the average biologist still hasn't heard of that and doesn't believe it when you tell him. But it is a fact and it was replicated. And that's how it's done. The living system can generate and has these electrogravitational waves, these squeeze waves, these scalar EM waves, the part that Heaviside left out. Living systems have generated since the beginning of time. It's very weak as far as power goes, but if you keep right on pouring it into the nucleus, you can change the nucleus. The nucleus will order and change and charge up with that pattern. That's how it's done. And it's fairly simple to be done between isomers of the elements, of the isotopes. General relativity and Kaluza-Klein geometry now apply, because when you go into the nucleus, you've moved into higher dimensions. How many? As many as you wish. But you've got to have at least 5 dimensions to capture a unified field theory of gravity and electromagnetics. Now, when Heaviside threw out the scalar component before 1900, it meant that somebody could come along now for special relativity and put it in 4 dimensions. But did he have electromagnetics in there? Nuh-uh. No. You can't really fit electromagnetics correctly and have gravity in there too in 4 dimensions. If you have a 4-dimensional theory of electromagnetics, you ain't got gravity. If you've got gravity in there, you ain't got electromagnetics. It won't fit. But if you'll add 1/5 dimension, which Kaluza did in 1920s, you can unify, again, electromagnetics and gravity. This paper was published on the recommendation of Albert Einstein. So now we must have Kaluza-Klein at least 5-dimensional geometry. By the way, Kaluza showed that where the extra dimension went, you could model it as wrapped around each point in our 3 space. Now in that model, electromagnetic waves do not travel through 3 space. Rigorously, they slither around the little surfaces around every point in 3 space along their direction of travel. That's a quite important distinction. If they penetrate the point, that's gravity. If they slip and slither around it in the 5th dimension, that's electromagnetics. And that's Kaluza-Klein theory, not Tom Bearden. They just don't make it quite that simple and clear. What do we got here? Guess we got a space. Now, in the past, I've given you a piece of information because I didn't want you to hurt yourself. I gave you spatial opposition of positive energy, positive time waves. And those are very weak. You get very weak gravitational effects and very weak inertial effects. You won't kill anybody with that. You won't kill yourself. But this one is powerful. Specifically, it can be 9 times 10 to the 16 times as powerful. You make a time-reversed wave, which we're going to go into with a full explanation here. You're going to get the full treatment tonight. I'm not going to cut it short. If you get tired, just go. If you want to get it, stay, because I'm going to make it real simple. But if you take a normal wave, which I've shown as little sine wave here, one oscillation, and you make its time-reversed or time-reversed replica, it's exactly like it in space. It fits exactly with it spatially, but the time dimension is reversed. Now the stress of those 2 waves that they're locked together is totally on time dimension. That's a highly compacted space dimension. And you get one going up, one coming back, so you get a c² type factor out of this thing. That gravitational wave, and that's what it is, that scalar wave can be up to 9 times 10 to the 16th times as strong as the one I've told you about in the past. And this is the one you do if you want to do antigravity. You got your ears open? You listening? All you have to do antigravity, all you want in any university laboratory in this country is make a pumped phase conjugate mirror at 100 to 400 hertz. Let me say that again, and I'm not going to answer any questions on it. All you have to do, if you want to make all the antigravity you wish to make, and any university laboratory in this country can do it, it's simple, doesn't take much power, is make a pumped phase conjugate mirror between 100 and 400 hertz. Enough said. Okay, a photon is a piece of energy and a piece of time welded together with no seam in the middle. It's a piece of what we call action, which has the dimensions of angular momentum. We usually show that as Planck's constant h. Aha! H is always positive. You've got to have something called a brick called action, but the brick can be made 2 ways and still be positive. You can make it with a piece of positive energy and a piece of positive time you weld together, and the product is still positive. You can make it with negative energy and negative time, and it's still positive. Now, the first one is a photon, and that's something that comes off of interaction with a negative charge, and it'll give you positive time interaction as it continues. It'll also give you entropy, because that will tend to more and more disorder. And the law of entropy, the second law of thermodynamics, ruthlessly applies. Now, what's the assumption in that law? Your professor never told you it had assumption because he didn't know it. The assumption is it's only for positive time critters. It does not apply to negative time critters. The negative of the law applies for negative time critters. It backs up. Instead of tending to more and more disorder, it tends back to order. So don't you worry about the universe running down. It's running back up to order just as fast as it runs down to disorder, but in negative time. But the internal part of every atom is already filled with time-reversed critters. Now,